morning student friends. Today we will start unit 5 advanced farming processes. First of all we will see the introduction of this chapter. Advanced farming processes. Now what is the difference between conventional farming and advanced farming process? In short we will see this. In conventional farming, conventional machines are used for the deformation of metals like extrusion machine, again press machine, bending machine, rolling machine, forging equipments. All these are the conventional farming processes in which there is a contact between tool and the workpiece. And in advanced farming processes we are using single energy or combination of energies to deform the metal, and rate of deformation is more in case of advanced farming process, and this process is applicable to those metals which are not possible to work by using conventional farming processes. In this case we can use explosive energy, electric energy, magnetic energy or hydraulic energy for the deformation of metals. The metals which are comparatively brittle, whose deformation is not possible by conventional farming processes, to these metals we can use these advanced farming processes. This is the introduction about this advanced farming process. In this case, for deformation of metals we are using single energy or combination of energy. That energy may be explosive energy, electric energy, magnetic energy, hydraulic energy or any other types of energies which is suitable to use for the deformation of metals is selected, and deformation of the metal is achieved by using these advanced farming techniques or the processes. Now this is first is high energy rate farming process. Larger energy is applied for short interval of time. On a workpiece we are applying larger energy. Here waves are created, pulse waves are created, and these waves are impacting on the surface of workpiece so that you can achieve the desired deformation to the metal. High particle velocities are produced in contrast with the conventional forming process. In conventional forming process directly the load is applied by the plunger. In case of forging we have seen the plunger descends in the downward direction and the plunger is applying the compressive force on the piece of work. But in this case high particle velocity is produced and it is directly striking on the surface of workpiece to deform it. The velocity of deformation is also very high, and hence these are also called as a high velocity forming process. This high energy rate forming process is also called as a high velocity forming process because particle velocity is very high. Particles are produced in this process. We are producing the particles, and the velocity of that particle we are using for deformation of metal. Many metals tend to deform more readily under extra fast application of the force. Extra fast application of force we can achieve and we can go for the deformation. Understood? Large parts can be easily formed by this technique, and we have seen in case of conventional forming processes there is limitation of the cross section. If cross section is more, it is difficult to achieve its deformation. But this convention, in case of advanced forming process we are using the energy for the deformation. That's why the larger cross section parts we can work, or the workpiece we can work. Now we will see the advantages of this high energy rate forming process. Production rates are higher as parts are made at a rapid rate, means this process is faster as compared to conventional forming process. Die costs are relatively low. In case of conventional forming, I told you the dies are made up of tool steel or die steel or tungsten carbide, and their machining cost is also more, but in this case dies are having a lower cost. Tolerances can be easily maintained, which is difficult to maintain in case of conventional forming process. Versatility of the process means this process is applicable to most of the metals which are difficult to work by using conventional forming process. On that metals also we can work satisfactorily. Minimum or no spring back effect on the material after the process. Now in conventional forming process, if we are considering about the punching or piercing operation, in that case the material slightly goes to its original state. That is called as a spring back effect. After deformation the material regain slightly its original size and shape. that effect is called as a spring back effect, and this is not happening in case of this high energy rate forming process. Production cost is low as power hammer is eliminated in this process. I told you in case of forging operation we are using power hammers up to 1500 ton capacity, and this is not required in this case. That's why cost of the process is less. It is economically justifiable process. Complex shapes can be made much easily as compared to conventional forming. Now we can see that if in case of punching or piercing operation, if the die is made more and more complex, then chances of attaching the workpiece to that dies are more. This is not happening in case of high energy rate forming process. The required final shape is obtained in one stroke, thus eliminating intermediate forming steps or the pre-forming dies. These intermediate forming steps and pre-forming dies, these are required in conventional forming process. We have seen the manufacturing of a spanner or the manufacturing of connecting rod of the IC engine while studying the forging operation. In that many steps are involved, but in this case only in one step we are producing the part. That's why this is very easy process we can say, or it is a profitable process, suitable for low range, suitable for range of production volume such as small number, batch or the mass production. Now there are three types of productions in the industry, that is batch type production, mass production or the low production. Means in a small quantity also we can produce the parts, but this high energy rate forming process is applicable to all these three types of productions, that is small quantity production, batch type production or large production or the mass production. Now limitations we will see. Highly skilled personnel is required to operate the machine, because complexity of the machine is more. That's why skilled labor is required. Not suitable for highly brittle materials like cast iron. Highly brittle material, this process is not applicable, but comparatively brittle materials we can form by using this high energy rate forming process. Source of energy may be chemical explosive or the electrical, and it must be handled carefully, because explosive we have to use TNT or RDX as an explosive, or electric energy we have to use as a three phase. That's why handling of that source of energy is difficult or the cumbersome task in this process. Government regulations or the safety norms the industry has to follow if the industry is working on these types of processes. Dies need to be much bigger to withstand high energy rate and shocks to prevent the cracking. Understood? That is the limitation of the process. Design of the die must be high enough so that it can withstand the pressure exerted by the energies. Controlling the application of energy is critical, as it may crack the die or the work. In some of the cases, if energy is going beyond the control of the operator, then it may produce a crack inside the work or it may damage the workpiece. Understood? These are the limitations of high energy rate forming processes. Now we will see the applications. In a shipbuilding, to form the large plates up to 25 thick mm plates we can form by using this high energy rate forming process. Bending of thick plates we can achieve up to 25 mm thickness plates. Bending we can achieve by this technique. Radar dishes also we can work. Understood? Radar dishes. Radar is used to get the directions, and that dishes or for the antenna dishes are required, and these dishes are formed by using this high energy rate forming process. Elliptical domes used in the space applications are also produced by this process. This is high energy rate forming process. In the next lecture we will see the other process.